I welcome you all for this presentation. In this presentation, we are going to discuss about extended Euclidean algorithm. Here also we are going to solve a problem using extended Euclidean algorithm. So already we have seen about Euclidean algorithm. Euclidean algorithm is to find the GCD of two numbers. So this is extended Euclidean algorithm. So from the name itself we understand something extended from that Euclidean algorithm. So Euclidean algorithm we are used to find GCD. So this extended what it finds means it compute two extra values, that is x and y. So what is the need for computing this x and y value is to find the inverse of a number. So in order to find the inverse only, mainly we are using this extended Euclidean algorithm. So this extended Euclidean algorithm calculates not only GCD but also it computes x and y value. So what is x and y value means? How we are representing, that is ax plus by equal to d. So already we know what is how to compute GCD using Euclidean algorithm. So what is a here? A is the dividend and b is the divisor. D is the GCD of a and b. So this a into x, that is this a dividend into some value plus divisor into some value must be equal to GCD of dividend and divisor. So this is the meaning. So using this, we are finding out the inverse of a number. Using this extended Euclidean algorithm, we are finding the inverse of a number. So here we are getting two values, x and y. So among these two values, any one value must be the inverse of this particular number. So let us see how we are calculating that. So all of you know how to calculate Euclidean algorithm. Suppose if you are not aware how to calculate how to compute GCD using Euclidean algorithm, please see the previous presentation how to compute GCD using Euclidean algorithm. Now we are going to find out how we are calculating this x and y value. So how we are finding it out means the same Euclidean algorithm procedure you have to find. In addition to that, you have to find this x and y value. So this x and y value computation is given here and this x and y has to satisfy certain condition. So here from 1 onwards only, I equal to 1 onwards only, we are calculating the GCD computation. So here initial steps we need, two initial steps we need, that means I equal to minus 1 and I equal to 0, two steps are required. So initially we are having considering these values as x minus 1 equal to x the base minus 1 equal to 1 and y base minus 1 equal to 0 and x not equal to 0 and y not equal to 1. Why we are considering this value means from next onwards we have to use this value. So only we are using this. So how we are x minus 1, x minus and x naught, y minus 1 and y naught. This is the initial value. So there is no change in that. So from this value only we are calculating x1, y1, x2, y2, all those things. So x1 how we are computing is x minus 1 minus q1. What is q1? This position quotient into x naught, previous x value. So we need to use previous x value and previous x value in order to find the corresponding x value. Likewise y value also y minus 1 minus quotient q1 into y naught. So previous two values we have to consider in order to compute the current x and y value. So let us see the example. So here using extended Euclidean algorithm compute 1759 inverse mod 550. So mainly extended Euclidean algorithm is used to find the inverse of a number. Here we are going to find the inverse of this particular number. Suppose you are asked to find the inverse means what is the meaning? 1759 into some value must be congruent to 1 mod 550. So this is the meaning. So some value, that some value only you are going to find here. So it may be either x value or y value. Any value, any one of the value must be the answer for this question mark. So that value only we are going to find. So prior to that, it is extended Euclidean algorithm. Before that, first you have to use the Euclidean algorithm. Then only we are using this extended Euclidean algorithm. So here one more condition also you have to see here. Here you are considering 1, right? So the GCD of these two numbers must be 1. So always the GCD of these two numbers must be 1. If it is 1, then only inverse exists. Otherwise inverse does not exist. So first, for the safer side, first compute the Euclidean GCD of two numbers, and if the GCD is 1, then proceed to that in extended, that means x and y computation. So in the beginning onwards, if you are computing, means it's waste of time only. So first you have to compute the GCD and check whether it is 1. In order to confuse you also, sometimes some numbers are given, that number which is not having inverse. So you have to check whether GCD of these two numbers is 1. If 1, then proceed with this x and y calculation. So already I told you here we are having -1 index and 0 index is there. So here we are starting from -1 index and 0 index, then 1, 2, likewise it goes on. So for the first position, 1 index only, we are starting this Euclidean algorithm computation. So what is A? Here also you have to compute. Suppose if it is given 550, find out the value 550, 1759, something like that is given, means you have to swap that value, because always in GCD computation we have to check A is greater than B, right? So here A is greater than B only, so no need to worry about that. So here 1759, sorry, 1759 and 550. What is the quotient? Quotient is 3 and the remainder is 109. Now R is greater than 0. So what you have to do? B becomes A, right? 550 and B becomes 109. That means A becomes B, A equal to B and B equal to R we are using. Now if you are dividing, the quotient is 5 and remainder is also 5. Now R greater than 0, that is remainder greater than 0. What we are doing is A equal to 109 and B equal to 5. Now quotient is 21 and remainder is 4. Next what we are doing, R is greater than 0. So A equal to 5 and B equal to 4. Now the quotient is 1 and remainder is 1. R is greater than 0. So what we are doing is A equal to 4 and B equal to R. Now quotient is 4 and remainder is 0. So here now R greater than 0 means condition fails, right? So we have to stop. And what is the GCD value? This is the GCD value. So GCD of these two numbers is 1. So now we found that GCD of these two numbers is 1. Now what we are going to do is this extended version, that means x and y value computation we are going to do. Already we have seen that initial value, that is x index -1 and x index 0 is 1, 0 and 0, 1 we have to consider. So -1 index x value is x -1 is 1 and y -1 is 0. Next what we are considering, this one x naught value is 0 and y naught value is 1. Now we are going to compute x1 value. What is x1 value? X -1, that is 1. 1 minus q1. Q1, what is q1? It is 3. 3 into x naught, 0. So any number into 0 is 0 only. So the value is 1. Next y1, the same procedure you have to follow. That is previous x value you have to consider. That is 0 minus q1, 3 into 1, which is equivalent to -3. Next what you are considering, here what you have to consider, previous x value, that is 0 minus quotient is 5. 5 into previous x value, it is 1. So it becomes -5. Next here previous y value, that is 1 minus quotient, it is 5 and previous y value is 3, -3. So if you are computing, you are getting the answer as 16. Sorry, 16. Next this x3 x3 how we are computing? Previous x value, that is 1 minus quotient is 21, 21 into minus 5. So the answer you are getting is 106. So likewise you are computing for y. How you are computing? It is previous y value, that is minus 3 minus q1, that is 21 into 16. So here you are getting the answer as minus 339. Likewise here you are getting the answer as minus 111 and here 355. So whenever the remainder is 1, because we know that GCD is 1, right? So in which position you are getting this remainder as 1, there you have to stop. So this is the final x and y value. So this extended Euclidean algorithm is used to find the x and y value, right? So this is the x and y value. So what does x means? Here it is going there. So x equal to minus 111 and y equal to 355. So I already told you that among these x and y value, any one value must be the inverse of this number, right? 1759 inverse, right? So here you have to find out which one, whether most of the students they used to think is here one value is negative and one value is positive. So we have to consider the positive value as inverse. It is not the case. So what you have to do here already we have seen, right? So 1759 into some value must be equal to 1 mod 550. That some value only we are calling it as this inverse value, right? So here minus 11 minus 111 means we have to apply this mod value. So minus 111 becomes minus 111 mod 550. So what is the answer? 111550, it is 439. So another is 355 mod 550, it is 355 only. So now you have to apply these two values here, that is 1759 into 439, whether it is equivalent to 1 mod 550. Another is 1759 into what is the next value? 355 is equivalent to 1 mod 550. So which one you are getting as 1 mod 550? 1759 into 439 only you are getting as 1950, 1 mod 550. So this value only you are getting as 1 mod 550. And this value you are getting some other value like I think 195. 195 you are getting. So 195, it is not correct, right? So 439 is the inverse of 1759 mod 550. So what is the inverse? It is 439. So how we got this 439? This x value only gives the answer as 439. So 439 is the inverse. So this way only you have to find the inverse of two value. So in the extended Euclidean algorithm, what we are finding is, we are finding the GCD. In addition to that GCD, we are finding x and y value. What is the need for computing x and y value is to find the inverse of a number. So here among these x and y values, one of the values must be the inverse of that number. So this way only we are finding it the inverse. And before proceeding to that extended version of this algorithm, you have to check whether the GCD of two numbers is 1. If GCD of two numbers is 1, then only inverse exists, otherwise inverse does not exist. So computing this doesn't make any sense. Okay, I think all of you understood this extended Euclidean algorithm. Thank you.